There's a photograph sitting in NASA's archives right now that almost never existed. It shows 6 planets, hundreds of millions of miles apart, captured in a single sequence by a spacecraft that was never supposed to take it. One of those planets is Earth. In that image, Earth is not a blue marble. It is not the glowing sphere from the Apollo missions. It is less than a single pixel. A speck of light caught in a scattered sunbeam, so small that if you did not know exactly where to look, you would never find it at all. When the scientists on the Voyager imaging team finally saw it, developed and printed and laid out on a table at the Jet Propulsion Laboratory, the room did not erupt into celebration. It went quiet. People who had spent years staring at raw data, at pixel counts and exposure times and radiation readings, found themselves looking at something they did not have words for. This is not science fiction. This is what happened on February 14th, 1990, when Voyager 1 turned its cameras around for the last time and left scientists speechless. Nobody told you the full story of how close it came to never happening. That is the first thing you need to understand before anything else here makes sense. The photograph you have probably seen, the pale blue dot floating in a diagonal ray of light, gets treated like a footnote in most retellings of the Voyager mission. A pretty picture, a poetic closing shot. That framing is not wrong, but it is dangerously incomplete. It leaves out the decade of resistance inside NASA. It leaves out the engineers who thought the idea was reckless. It leaves out the fact that the final images were captured with barely half an hour to spare before the cameras were shut off forever. And it leaves out what happened in the days after, when the photographs finally reached the scientists who had fought to make them possible, and what that moment actually did to the people who witnessed it first. To understand what made those final images so devastating in their emotional weight, you have to go back further than 1990. You have to go back to 1977 when Voyager 1 launched from Cape Canaveral with a single clear assignment. Fly past Jupiter, fly past Saturn, collect data, send pictures. That was the mission. 5 years, maybe a little more if the spacecraft held together. Nobody involved in building it imagined a scenario where, more than a decade later, engineers would still be arguing about what to do with its cameras. Voyager 1 completed its primary assignment in November 1980. Sailing past Saturn and delivering images of the ring system that rewrote what humanity understood about that planet. At that point, technically, the job was finished. The spacecraft kept moving anyway, accelerating outward through the solar system at roughly 38,000 miles per hour, carrying instruments that were still fully operational and cameras that still worked but had nothing left to look at. No more planets waited ahead on its trajectory. The cameras had done their job. The obvious next step, the step almost everyone at NASA assumed was coming, was to power them down and preserve whatever electricity remained for other instruments. One person disagreed. Carl Sagan, a planetary scientist who had been part of the Voyager imaging team since before launch, had been carrying an idea in his head since 1980. The same year the primary mission ended. He wanted Voyager 1 to turn its camera around, not toward another planet, toward home. He wanted a photograph of Earth taken from farther away than any photograph of Earth had ever been taken before. A portrait of the entire solar system with Earth reduced to its true size within it. It sounds obvious in hindsight, almost inevitable. At the time, it was anything but. The technical objections were immediate and serious. Pointing Voyager's camera back toward the inner solar system meant pointing it dangerously close to the direction of the sun. A single miscalculation, a slightly wrong angle, could flood the camera's optics with sunlight and destroy the imaging system permanently. There was no way to send a repair crew. There was no way to test the camera afterward and try again if something went wrong. Whatever happened would happen once, and it would be final. Beyond the technical risk, there was institutional resistance. NASA in the 1980s was managing dozens of competing priorities, and Voyager 1's operating budget did not have unlimited room for symbolic photography. Some scientists on the mission argued that the picture had no research value. It would not measure atmospheric composition. It would not reveal geological data. It would not answer any open scientific question. It would just be a picture, aesthetically interesting perhaps, but not the kind of thing that justified risking irreplaceable hardware 15 years into a spacecraft's operational life. Sagan kept pushing anyway. He believed, and he said so repeatedly in meetings and internal memos, that the value of the image was not scientific, in the traditional sense. It was philosophical. It was about perspective. He believed that if humanity could see itself from that distance, reduced to something almost too small to detect, it would change how people thought about their place in the universe. For 9 years, that argument was not enough to move the decision. It took until 1989 for the idea to gain real traction, and even then it almost did not happen in time. The window for taking the photograph was closing permanently because the Voyager team had already scheduled the deactivation of the cameras to conserve power for the instruments that would matter for the spacecraft's long interstellar journey. Once that shut down, command was sent, there would be no undoing it. No future opportunity, no second attempt. The final approval came only after Richard Truly, NASA's administrator at the time, personally intervened to make sure the photograph sequence would be completed before the cameras went dark for good. Even with that approval secured, the operation required extraordinary precision. Engineers had to calculate the exact orientation needed to protect the camera's optics while still capturing each of the intended targets. They had to account for a spacecraft that was, by then, more than 3.7 billion miles from Earth, so distant that every command sent from mission control took hours to arrive, and every confirmation that something had worked correctly took hours more to come back. On February 14, 1990, the sequence began. Voyager 1 executed a series of camera maneuvers designed to capture what would later be called the family portrait, an attempt to photograph as many planets in the solar system as geometry would allow from that extraordinary vantage point. The spacecraft captured 60 individual frames over the course of the sequence: Neptune, Uranus, Saturn, Jupiter, Venus, and Earth. Mercury was lost, too close to the glare of the sun to register safely. Mars was lost too, its light scattered and drowned out by stray reflections inside the camera housing. Pluto, despite still being considered a planet in the classifications of the era, was too small and too dim for Voyager's camera to resolve at that distance. 6 planets, 60 frames. And within those 60 frames, one single image of Earth that nobody in that control room was fully prepared for. The frame containing Earth shows almost nothing at first glance. A field of black, streaked with faint bands of scattered light where sunlight bounced inside the camera's optical system, an unavoidable artifact of pointing so close to the sun. And within one of those diffuse light bands, if you know exactly where to look, is a single point occupying roughly 1/10 of 1 pixel of the image. That point is Earth. Every person who has ever lived, every civilization that has ever risen and fallen, every mountain range, every ocean, every war, every symphony, every love story, every single human life across the entire span of recorded history, compressed into a fraction of a pixel of light, suspended in the glare of a sun 3.7 billion miles away from the camera that captured it. 34 minutes after that image was taken, Voyager 1's cameras were powered off, permanently. They have never been turned back on since, and they never will be. The timing of that shutdown is the detail that tends to stop people cold once they understand it fully. The entire 60-frame sequence, including the photograph of Earth, was completed in the very last operational window available before deactivation. If the approval had come even a few weeks later, if Richard Truly had not intervened when he did, if a single command in that sequence had been delayed by half an hour, the cameras would have gone dark without ever completing the portrait, and the most reproduced photograph in the history of space exploration would simply never exist. Nobody would know what they had missed, because there would be no image to mourn. It would just be an absence nobody thought to notice. But the story of that day is not only about how close the photograph came to never being taken. It is about what happened in the weeks after, when the raw data finally made its way back to Earth and was processed into something scientists could actually look at. Sending an image across billions of miles of space in 1990 was not instantaneous. The data had to be transmitted in pieces, received by antennas in the Deep Space Network, and reconstructed on the ground before anyone could see anything resembling a finished picture. When the imaging team finally had a processed version of the Earth frame in front of them, several people who worked on the Voyager project have since described the moment in strikingly similar terms. Not excitement in the way you might expect from a scientific team unveiling a new discovery, something closer to stillness. People who had spent years working with this spacecraft, who understood exactly how far away it was, who could recite the distance in kilometers without checking their notes, still found themselves unprepared for what it meant to actually see it. Numbers on a page describe distance. A photograph makes you feel it. Sagan himself would later write about that image in terms that went far beyond mission reporting. In his 1994 book, named directly after the photograph, he described looking at that pale blue dot and being struck by how absurd human conflict looked from that vantage point. Every war fought over a few miles of territory, every dispute over resources or ideology, every claim to some corner of that dot as uniquely important, all of it compressed into something smaller than the width of a human hair held at arm's length. He wrote about how the image did not just show Earth from a distance, it showed the entire concept of human importance from a distance, and from that far away, importance did not survive the trip particularly well. That was the philosophical argument he had been making since 1980. The one that had taken 9 years to convince anyone to act on. Once the photograph existed, it did not need to be argued for anymore. People could simply look at it. What made scientists at JPL and across the broader Voyager team fall silent was not only the smallness of the dot, it was the compounding weight of everything that photograph represented about the mission itself. This was not a picture taken by a satellite in Earth orbit, capable of returning home for maintenance or replacement. This was a spacecraft that had already flown past Jupiter and Saturn, already completed its assigned mission a decade earlier, already been operating on borrowed time for years, and it had used its very last moments of vision to look back at the place it came from. There was something almost unbearably poetic in that sequencing, whether or not anyone at NASA had planned it that way. A machine built by human hands, sent outward to study distant worlds, chose as its final visual act before going permanently blind a look homeward. Several engineers who worked closely with the Voyager imaging systems have described that specific detail, the fact that this was the very last image before total camera shutdown, as the piece of context that turns a nice photograph into something closer to a farewell. The scientific community's reaction unfolded gradually rather than all at once. In the immediate aftermath, most public attention still focused on the broader family portrait sequence, the novelty of seeing 6 planets photographed together from such an unusual angle. It took time for the Earth image specifically to separate itself from the larger set and become recognized as something singular. Part of what drove that shift was Sagan's own advocacy after the fact. He gave lectures referencing the image, he wrote about it, he used it deliberately and repeatedly as a teaching tool to make audiences confront the scale of the universe in a way raw statistics never could. Astronomy textbooks eventually incorporated it. Documentaries built entire segments around it. But the earliest reactions, inside the rooms at JPL, where the image was first processed and reviewed, were quieter and more personal than any of that later public attention would suggest. People who had built careers around interplanetary science, who understood on an intellectual level exactly how small Earth was in cosmic terms, still described being caught off guard by what it felt like to actually see the proof. Part of what makes the image so difficult to fully process is the specific type of smallness it captures. Photographs of Earth taken from the moon or from low orbit still show a recognizable planet, a blue and white sphere with continents you can trace with your finger. This image shows nothing like that. There is no sphere. There are no continents. There is only a single point of light, and even that point required careful processing and expert analysis to distinguish it from the scattered artifacts of sunlight surrounding it. Untrained observers looking at the raw frame for the first time often cannot find Earth at all without someone pointing directly to the pixel in question. That is not a flaw in the photograph. That is the entire point of it. Sagan wanted an image that did not flatter human significance. He got exactly that. There's a layer to this story that gets mentioned less often, which is what the decision to take this photograph cost the mission in resources and risk, weighed against what it delivered in return. From a purely scientific standpoint, the family portrait sequence and the Earth image within it added essentially nothing to Voyager's data catalog. It did not advance understanding of planetary atmospheres or magnetic fields or ring composition. Every dollar and every watt of power spent on that sequence was, by the strict metrics NASA typically uses to evaluate mission value, difficult to justify. And yet, it is likely the single most consequential image the Voyager program ever produced, arguably more widely recognized than any of the genuinely groundbreaking scientific data the mission returned from Jupiter and Saturn. That tension between what is measurably useful and what is immeasurably meaningful sat at the center of the decade-long argument over whether to take the photograph at all, and it remains at the center of why the image continues to resonate decades later. The engineers who had originally opposed the idea on technical grounds were not wrong to be cautious. The risk was real. Pointing an aging, irreplaceable camera system back toward the glare of the sun genuinely could have destroyed it before the sequence finished. And if that had happened during an earlier frame in the series, humanity might have lost not just the Earth photograph, but the images of Neptune, Uranus, Saturn, Jupiter, and Venus as well. The entire family portrait was gambled on a single sequence of maneuvers executed by a spacecraft billions of miles away, with no possibility of a dry run and no chance to recover from a mistake. The fact that it worked, that all 60 frames were captured cleanly and the cameras were deactivated on schedule immediately afterward without incident, is as much a testament to the precision of Voyager's engineering team as it is to Sagan's philosophical persistence. What happened after the cameras shut down is a separate story from the one this photograph tells, but it deserves at least a mention here because it changes how the final images should be understood. Voyager 1 did not go silent in 1990. Its other instruments, the ones measuring cosmic rays, plasma waves, and magnetic fields, kept operating for decades afterward. The spacecraft eventually crossed into interstellar space in 2012, becoming the first human-made object to leave the solar system entirely. And it has continued transmitting scientific data ever since, even as instrument after instrument has been powered down to conserve its dwindling supply of electricity. But it has done all of that blind. Every measurement Voyager 1 has taken since February 14, 1990, every reading of magnetic field strength, every detection of plasma oscillation has been recorded by a spacecraft that can no longer see anything at all. Its final act of vision, the very last thing it ever looked at before going permanently blind to the universe around it, was the world it left behind. That is the detail that tends to leave people without an immediate response when they fully absorb it. Not simply that Earth appears as a fraction of a pixel in a field of scattered light, though that alone is enough to reorient how most people think about scale. It is the sequencing. It is the fact that a machine capable of photographing 6 planets, capable of ending its operational vision on any final image it chose, ended it there, looking home. Whether that was poetic accident or intentional symbolism depends on which member of the Voyager team you ask, and accounts differ on how deliberate the ordering of the sequence truly was. But the effect on the people who first saw the developed image, the effect that left seasoned scientists at a loss for words in a room full of instruments and printouts and years of hard-won expertise, had nothing to do with orbital mechanics or optical engineering. It had to do with recognizing all at once and without warning exactly how small the entirety of human experience looks from far enough away, and understanding that the last thing this particular machine would ever see was us. There is also a quieter, more human dimension to this story that rarely makes it into documentaries or textbook footnotes. The image processing team that reconstructed the raw data into a viewable photograph was working with technology that, by today's standards, was almost primitive. There was no modern image editing software, no simple way to enhance faint signals against background noise with the push of a button. Extracting that single point of light representing Earth from the scattered glare surrounding it required painstaking manual analysis, cross-referencing known coordinates, calculating exactly where Earth should appear within the frame based on the spacecraft's precise position and orientation at the moment of capture. Without that calculation, without scientists already knowing exactly where to look, the photograph would likely have been dismissed as an unremarkable frame full of lens flare and stray light. Indistinguishable from dozens of other unusable images the mission had collected over the years, the significance of the picture did not announce itself. It had to be found deliberately by people who already understood what they were looking for and why it mattered. That detail matters because it mirrors something larger about the entire effort behind the photograph. Nothing about this image was accidental or effortless. Every part of it, from Sagan's original proposal in 1980, through 9 years of institutional resistance, through the razor-thin timing of February 1990, through the delicate risk calculus of pointing an irreplaceable camera near the sun, through the labor-intensive process of finding Earth within a frame not designed to make it easy, was the product of sustained human insistence against a system that kept finding reasons not to bother. The photograph exists because a small number of people refused to accept that a picture with no measurable scientific return was therefore a picture without value. That argument, more than the optics or the orbital mechanics, is the part of this story that continues to resonate with anyone who hears it in full, because it says something about which kinds of value get recognized immediately and which kinds take years of quiet persistence to earn their place. The photograph exists today exactly as it was captured that day, unchanged, uneditable, a fixed record of 1 moment more than 3 billion miles from home. Voyager 1 has continued its journey outward ever since, carrying that final glimpse of Earth along with it, deeper into a darkness its cameras will never register again. Somewhere out past the edge of everything humanity is ever directly. Measured, a blind spacecraft moves forward at 38,000 miles an hour, its last photograph forever fixed on the world it came from, a world so small in that image that most people, looking at it for the first time, need to be told exactly where to look before they can find themselves at all.